Well, good morning, ladies. Oh, it is Thursday, April the 2nd, 2020. I don't even know what day we're on of this illustrious journey, but I'm just going to tell you, we can do this. So I've kind of noticed as I've been out and about and just watching, some people are just not trying to push through this at all. They've just given up. And so my advice to you today is to get mad at it and push through like you've never pushed through before. And we have 1 month left of this. So hold on, let me count the days. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 days left in this class. Okay? If that doesn't put life into perspective, I don't know what does. But we have 9 days left. Okay? So hang with me for 9 days and we will get through this. So keep that in mind as you struggle. Just push forward, reach out to me. Hopefully I can give you some encouragement. So today we want to look at 9.3, and this is all about simulations and applications of probability. So we've been finding probability. So a simulation is a technique used to act out a problem by conducting an experiment whose outcomes are analogous to the original problem. So lots of times, and you'll see a couple of these, they use various hypotheses, then they construct a model solution, and then actually run the simulation. So take, for instance, suppose you wish to simulate a proportion of males to females in a group. So we're going to assume that 50% males, 50% females. So simulations that we could run. We could roll a dice. If I get a 1, 2, or 3, it's a boy. If I roll a 4, 5, or 6, it's a girl. Okay, I could flip a coin, heads for boys, tails for girls. I could write boy and girl on a piece of paper and put it in a hat, draw it out. I could create a spinner with half boy, half girl. And I can also use a random number table, and I'll explain how to do that with an example later on. And let even numbers be boys and odd numbers be girls. So, and you can go through and figure probability from that. So here's our first example. Suppose 1/3 of the population will vote in the presidential election. Simulate who will vote in a group of 100. Okay, so a couple of ways that you could do this. You could roll a die. So you want to roll it 100 times and you want to keep a tally. So, and this is going to be your tally marks. So it's 1/3. So when we think about a die, we have 6 options on a die. So 1/3 of 6 is 2. So that means 1 and 2. If I roll a 1 or a 2, that means I'm going to tally mark that you voted. If I roll a 3, a 4, a 5, or a 6, that means you didn't vote. So that's one way that you could use a die for that. You could also create a spinner. And so with a spinner, you could have 1/3 of the spinner that for voted, and the rest of the 2/3 of the spinner not voted. So again, you could spin the spinner 100 times and keep track, and that's the simulation that will show that. Okay, so here's an activity to show what a random number table is. And again, random numbers can be generated in the back of your book. There's a random number table that you can use. But we're going to use this example. A baseball player has a batting average of .400. So what that means is they're going to getting a hit on any particular time at bat is .400. So that's 40% of the time. If we change that to 40% of the time, they're going to get a hit. So estimate the probability that he will get a hit, at least 1 hit in his next 3 times at bat. Okay, so if we use a random number table, what we want to do is think about the digits. So the digits in any number can be 0 to 9. So that means there's a total of 10 digits. So if we take 40%, because that's how much he's batting, okay, 40% of the time he's getting a hit. 40% of 10 is 4 digits. So this is how we're going to create our random number, how we know whether it's a hit or not a hit. Okay, so because 40% of 10 is 4, that means if I take the first 4 digits, 0, 1, 2, or 3, that's going to signal a hit. If I have a 4, 5, 6, 7, 8, or 9, that is not a hit. Okay, So using a random number table, a hit is represented by any digits 0, 1, 2, or 3. Okay, so I've chosen 50. There's 50 trials here, so there's 50 random numbers right here. Okay, so looking at this, a 0, 1, 2, or 3 appears, if I go through and mark those, appear in 42 out of 50 trials. 42 out of 50 trials. So if I go through and say, okay, a 0 appears here. A 0 appears, a 0, 1, 2, or 3 appears in this one, but it doesn't in 848, so that's not counted as one. So you just go through the number and say, okay, does a 0, 1, 2, or 3 appear? So it appears in 42 out of 50 trials. So that means that an estimated probability that he's going to hit 40% of the time is 42 out of 50, okay, or the probability of 0.84. So the question is, or was, estimate the probability that he will get at least one hit in his next 3 times at bat. Okay, so with that, it ends up being 0.84. The probability of that is 0.84. So that's how you use a random number table. Okay, another example. So let's go fishing. It's a beautiful day to go fishing, except the wind's kind of blowing. So to determine the number of fish in a certain pond, suppose we catch 300 fish and we mark them. So we know that 300 fish out of some number is marked, and throw them back into the pond. Suppose that the next day 200 fish are caught and 20 of those are already marked. These 200 fish are then thrown back in the pond. Estimate how many fish are in the pond. Okay, so we marked 300 fish. When we went fishing again, 20 of 200 that we got, okay, we fished and got 200 fish, 20 of those were marked. Okay, so if we think about, because 20 of the 200 fish are marked, we can assume that, if we simplify that fraction, 1/10 of the fish in the pond are marked, okay? Because we got 1/10 of the 200 we caught, okay? That's our probability, is 1/10. So let x be the total number of fish in the pond. So I want to take 1/10 of x is equal to 300, because that's the total number of fish we marked. So 1/10 of the fish out of that 300 that we marked, and if you solve for x, multiply both sides by 10, then you're estimating that there are 3,000 fish in the pond. 3,000 fish in the pond. And there's an example like this in your quiz today. Okay, the next thing we'll look at is odds. So we've looked at probability, but odds and probability are different. Okay, very different. So odds in favor of an event is the ratio. So again, we're looking at ratios of the likelihood of an event. Okay, so if we look at the odds in favor of rolling a 3 is 1 to 5. So where that comes from is the probability of rolling a 3 divided by the probability of not rolling a 3. And this is where it changes, is because it's not over the total options. Okay, it's over the probability of not rolling a 3. So that's where the 1 and 5 comes into play. Now, the thing about ratios is your top and your bottom, or your first number and your second number, should add up to your total options. So 1 plus 5 is 6, and when we roll a die, we have 6 options. So if we go the other direction, the odds against rolling a 3 is 5 to 1. So the number that comes first is, what other options do I have besides a 3? The number that comes second is how many options I get a 3. So it's the probability of not rolling a 3 over the probability of rolling a 3. Now, here's your formulas for that. Okay, so let the probability of A be the probability that A occurs and that A does not occur. Then the odds in favor of an event. Okay, you can do probability of the odds over probability of not achieving that. Remember, the line over the top means not achieving that. Okay, and if it's odds against your not achieving is on the top. Okay, so that's our formula there. Okay, so when we're converting between odds and probability, okay, between odds and probability. So remember, odds in favor, you want to refer to this page. So odds in favor means the number of favorable outcomes over the number of unfavorable outcomes, not the total. Odds against, it's just flip-flopped. So if you're starting out with odds, you then want to convert to probability, and these are our two formulas. So if the odds in favor, okay, of an event happening of m to n, then your probability is m over m plus n. So add these two together to get your total options. If it's probability against, it's n over m plus n. So make sure and read your questions as to, am I doing the odds in favor, odds against, and what am I find the probability. So here's a couple of examples that you can look at. These are odds in favor. All of these are in favor. Okay, the rolling a number less than 5, so it's not less than or equal to 5, it's just less than 5. So we have 4 options that are less than 5, so 4, 3, 2, and 1. And so 2 options then that are not less than 5. Okay, so 4 to 2, and when you simplify, it's 2 to 1. If you're finding the probability, then you can say the 4 over 4 plus 2. That's for the 6. Or the 2 over 2 plus 1. However you look at that. Okay, so you can go down through those. So again, converting from, on the left, converting from odds to probability. Odds to probability. And remember, probability should always be less than 1. Anytime you're doing probability, less than 1. Okay, so here's an example. Find the probability of making a totally black copy if the odds are 3 to 1 against making a totally black copy. So the odds against are 3 to 1. That means the odds in favor of making a totally black copy are 1 to 3. So the probability of making a black copy are 1 over 1 plus 3, or 1/4. So, and the part on the right is just for fun. It's not part of the problem. But hashtag future teacher probs, just so you know. Always work ahead because you never know when the copier will be down in the teacher's lounge. So it is a problem. So always work ahead or know where the secret copier is stashed. So, okay, the last thing I want to talk about is expected value. An expected value is we want to find out what's the expected value based on the probability. So how you find that is it's the probability times what is happening, the number of times. Are you earning money, or do you have a loss? So it's whatever the number is times the probability. So expected value is an average over the long run. Expected value can be used to predict the average or typical results of an experiment. And if the expected value is equal to 0, and this is important, if it's equal to 0, we say that the situation is fair. So an example of this is, suppose you pay $5 to play the following game. If you toss 2 coins, you receive $10 if you have 2 heads. You receive $5 if you have exactly 1 head. So your options there are heads or tails, heads. And you get nothing if no heads appear, so tails, tails. So it's asking, is this a fair game? So are the net winnings 0? So first of all, you have to take into account your winnings. Now, you have to subtract out what you paid to play. That's what people forget when they gamble. So if I get heads, I may win $10, but I paid $5 to play, so I would be up $5. If I hit a 1 head, either heads, tails, or tails, head, I get $5, but I have to subtract the $5 I play, so I get nothing. So in the long run, I have nothing. If I hit tails, I'm actually $5 in the hole because I didn't win anything and I paid $5 to play. Now, the probability of each. So you have 1 out of 4 tries to get a heads, 2 out of 4 tries to get a head and a tail combination, and then tails for 1/4 of the time. So these are your probabilities. So to find your expected value, you want to multiply your winnings times your probability. And then you want to add those together. Okay, so when you multiply and add, you end up getting 0. And remember, if the expected value is 0, it is a fair game. Now, I'm about to time out, so be sure to look for video number 2 to finish out the notes.